Analytical chemist Jonathan Sweedler and his team at the University of Illinois are working to understand the function of individual cells in the nervous systems of slugs and other animals.
So why study single cell? Trying to understand how, say, a muscle works, and maybe individual cells aren't important, but in cases of cancer, when the single cell starts to mutate, then you need to go to the single cell level.
They use a technique called mass spectrometry to measure the different chemical constituents in slug and other brain samples.
Every one of these lines is a different chemical from the brain. So because of what's happened with mass spectrometry, the discovery of new molecules in the brain is really accelerating.
Sweedler says sea slugs are a great model system for neuroscience because their neurons grow and grow throughout their lives.
This is the nervous system of the Aplysia californica we are looking at, and right here you can see that some of these neurons can actually get quite large, which makes it a little bit easier, gives you a little more material to work with.
Learning to turn specific chemicals in the human brain on and off could lead to new methods to diagnose and treat chronic pain, drug addiction, even neurological disease and mental illness.
And so we want to understand the chemistry, and more than that, we are discovering in every animal we've looked at new molecules that people didn't know were in the brain. Just as we find new molecules, there is actually the potential for having a therapeutic effect.
So next time you're feeling a little sluggish, take heart. They're smart enough to teach us a few lessons. For Science Nation, I'm Miles O'Brien.
VOA presents the following National Geographic program as we continue to explore the world around us.
I've been with this project with the rover since 2004 when we proposed the cameras that take all these beautiful color images. And, but my own story goes back to reading National Geographic in the early 1970s and the coverage of the Mariner missions and the Voyager and Apollo. So it's kind of trippy to be standing here right now. This is a landscape. Mount Sharp, you see to the upper left rising out of the scene in that direction. In the other direction, you don't actually see it here, but we will see it. You will see the wall of Gale off further in the distance. Mount Sharp is 3 miles high of layered sediment. The kinds of outcrops of rock that we've been looking at since we landed are more like ankle and knee high. And some of them are down underfoot, like the mudstone that we drilled. By the way, 2 years ago when we landed, if you said the first thing we drill is going to be a mudstone, and that we would find that it was actually a habitable environment, I wouldn't have believed you. So this has been an amazing 2 years. You see Curiosity carries its name on its arm. It carries its name on its sleeve. And what we are doing, we are geologists for the most part, and what we are doing is trying to read the history of this place in the layered rock. We call it stratigraphy, but basically the oldest rocks are at the bottom of a stack and the youngest are at the top. And so if you go like to the Grand Canyon in Arizona, for example, or Letchworth, I've been there many times, older, younger. So what you see here behind me is one of these landscapes in a place called Dingo Gap. This was just a few months ago. In the far distance, you actually see the north wall of Gale Crater. So we're trying to look at these rocks with the rover and try to understand the history that they're telling us about this place. Here's another place. We called this one Shaler, and this is layered rocks laid down by moving water in a stream. All of that orange-brown stuff you see, that's the dust. The rocks is the dark gray stuff. Everything we've seen in Gale has been sedimentary rock, and it's been various shades of gray. Here's another landscape, again, in the direction we are driving. Here you can actually see the wall of Gale off in the far distance, and you see a little bit of Mount Sharp off in this corner up here. In front of us, right in the foreground, is a little drift of sand, wind-blown sand. What we've been dealing with here is a very, very thin veneer of wind-blown sand, wind-blown dust, and all those little pebbles and cobbles you see. That's just the detritus as this rock breaks down and then wind carries it away. This is a story of we are right there by the bedrock. It is right under our feet. We can drive up to it. We can read this history, but we do have to deal with this veneer of dust and sand and pebbles here and there. Wind erosion is a big deal in Gale in allowing us to do our jobs. And if you look in the sort of the bottom middle of this picture, you'll see a little pebble, and behind it is a protrusion going back under the sand into the rock outcrop or into the rock face. A little pebble, and then this protrusion. That pebble protected all that rock behind it as wind blew sand and eroded that rock back, except where that pebble was. That's like one of my favorite pictures from this mission. Now here's a close-up. Like I said, sedimentary rock. This is bits of old rock. So think about the history here. There was rock on Mars. That rock broke apart, made sand and pebbles and cobbles and dust, and then that stuff was transported by wind or water and deposited in Gale. And then later, it becomes rock, okay? So sediment then becomes rock, and then even later, the wind is eroding that, leaving like that protrusion with the pebble, okay? This is a picture of one of the conglomerates that we saw, and this is a close-up, and you see a penny for scale, so you get some idea. These are actually very small pebbles, about the size of Lincoln's head. That penny is also on Mars, but not actually in this photo. I photoshopped that in to give you a sense of scale. But the rover carries that penny with it, and I love to use it for scale because we're all familiar with that. That was a conglomerate. Now I'm going to go to a finer grained sediment. This is a sandstone, okay? And what you're looking at is the sand is both the very dark gray mass that you see everywhere. You can't actually see the individual grains because they're actually smaller than the camera was resolving here. And then you see little protrusions, which are larger sand grains set in that finer sand. Those protrusions are there because of wind erosion. Those are resisting the blasting by the sand, so they stick out. But then at the bottom, you see a void. You see out of focus dirt in the background because this is a layer that's forming a shelf, an overhang, and the layer beneath it retreated back out of view. You can't see it. Now, everything you see in this picture that looks kind of brownish or reddish is just dust sitting on the rock. This rock is dark gray. Next slide shows the finest grained sedimentary rock we've seen, which is this mudstone, and the penny here is for scale again, and you see an area that the rover brushed. It has a little wire brush. We don't use it often, but when we do, it does a good job. Now let's look at that close up, okay? The camera on the arm can get right down, literally within an inch or so, and we can take these close-up views. Here now, you actually see grooves cut into the rock by the brush. So this rock is not really, really hard. It actually can get little grooves from the wire the wire brush as it moves. And you see some of the dust that's sort of generated as it swirls that up. But when we look at the rock itself, ignore the dust, ignore the grooves, we find that the grains are too small to see with this camera. And this is one of the highest resolution images ever taken outside of a microscope, on board the Phoenix lander. This is one of the highest, right down there with this camera, and we can't see the grains. So they are very, very fine grains. So let me talk briefly about some of the other tools. You've seen a lot of pictures. You get a sense that we can do a lot with pictures. But we also want to know about the chemistry of the rocks and the minerals that make up the rocks. This is the arm, is that white thing sticking down, and then the turret. And in the shadow underneath there, you see a little box called the APXS. That is a science instrument that is using X-rays, and it is measuring the chemistry of the rock there. So that is one of our tools. Here now is another brushed spot. This was just at the end of April. This was a sandstone, and remember the penny and the brush spot, so it's like 3 or 4 or 5 pennies across. But you see an array of dots